to start, I just wanted to give you an idea of what we're going to simulate, and also give you an idea of what using a GPU versus CPUs means in simulation. Okay, so these are some old benchmarks for Amber, and this is for a system that is 24,000 atoms. I mean, this is probably 100 kilodalton protein or something. So maybe 100 residues or so, I don't know, somewhere around there. So it's not a huge protein, but it's not super small either. And these are old GPUs. But if you look, you know, using 20 cores, 20 CPU cores, you're getting 40 nanoseconds a day. And using, you know, one of these GPUs, you're getting 600 to 800 nanoseconds a day, right? So there's a huge difference in simulation speed. And in fact, this is the same system, I think, yeah, MPT. No, go up here. Let's see. I think that was called I don't know what it's called. So this is, DHFR, that's a different one. This is actually, it's the smallest one maybe. Yeah, I can't, anyways, we'll go back to here. But anyways, with a smaller system, like you know, I think this is somewhere around 20,000 or 30,000 atoms, something like that. I can't remember what Jack is, but now with the A100s that are actually the GPUs on the Exceed server, you can get over this is generally what we use, but over a microsecond a day. So with a CPU, it would be, you know, even using, you know, 20 cores, it's going to be 100 nanoseconds a day, or yeah, maybe 100 nanoseconds a day or something, or less than that. And even when you get to larger systems, so you go up to this huge system, this is, I can't remember, STMV, some virus, 1 million atoms. And I believe they have this benchmark in here too. Myoglobin, the nucleosome, wow, okay. Here's STMV. They're getting 50 nanoseconds a day, even for 1 million atom actual. I think this must include water too. So, yeah, so anyways, it just gives you an idea of how long it takes to get a biologically relevant length of simulation. I mean, of course, there's a lot of things going on in biology, but for many things, you're going to need microseconds, if not milliseconds and seconds. And so that's why you need to use enhanced sampling methods. But just for these plain conventional MDs, this just gives you an idea that, number one, that if you want to get longer time scales and do things fast, you need to use GPUs. Otherwise, it's really slow. So, okay. The other thing that I wanted to start off with is, so we're going to be doing the tutorial. I put it on Slack that we're going to be doing. You just click on tutorials, and I put the link in there. There's a bunch of tutorials in here on the Amber website, and you go down to 5.1, and I guess the link was exactly to this tutorial. And this tutorial is actually pretty good throughout the whole thing from the start. But I just want to put this in context. So when you're working through, they'll put copy paste, that you kind of have an idea of what you're doing. And so this is the thing that we're simulating. And let me pull up my PowerPoint here that shows this a little bit better. So it looks a little bit strange, but there is an alanine amino acid residue in the middle here of the thing that we're simulating. It's called an alanine dipeptide, which is a little bit I guess it isn't really two alanines, although you can kind of see two alanines in there. But it's really an alanine with a cap on one end and a cap on the other end. And these caps are to make it so that the ends aren't charged, and sometimes you do that because in general, you know, if you're using a peptide, sometimes even experimentally you cap the ends. But you know, having a charge on the end maybe isn't the best for your system sometimes, and it's better to put caps. So anyways, that's what this tutorial is. It's just an alanine residue that has these caps on the end to get rid of the charges on the ends. And I also put up on Slack, there's a couple things up there that I think will trip you up during this tutorial if you haven't done it before. And there's one thing that I really want to make sure that everyone who runs this realizes. So the first, well, maybe I'll say this first because I think it's the most important. So if you're going to run this tutorial, do not just run it as is, especially this step 13. Because number one, when you hit go, it's going to take a day for it to run because we're not using GPUs for this simulation, okay? We're going to use CPUs, and it's going to take 16 hours if you hit go as written in the tutorial. We don't want to run for 16 hours. There's no reason to run for 16 hours. So what you do, instead of running it for 5 million steps, we're going to run it for 50,000 steps, okay? So we're going to reduce it by a factor of 100, okay? So just you'll see it when you get to this part. Maybe I should bring it up, but we'll go down to here. When I mean step 13, there's a little 5 here, 6, 7, 8, 9, 10. You know, we go down to 13. And in here, it says we're going to create this file, right? And there's this number right here under NSTlim, and you just need to, you know, hit delete, delete, and make it 50,000 instead of 500 or 5 million. I guess that brings up another point in this tutorial. How many of you have used like a command line editor on a remote server? How many have not done that? Okay, there's a few of you. You can use, you know, just text editors on your computer, but then that involves transferring files from your computer to the server and back. And also, I've noticed, unless you use the right text editor, unless you're careful, it can screw things up because the end of line notation it becomes a headache. So if you can, I would suggest trying to use a text editor that's on the server. The one that I use is called VI or Vim. And the way to bring it up is just VIM. You just type VIM in the server, and it's really clunky. It was written in the 60s or 70s or I don't know when, and it's really frustrating. But which one? Nano. Okay. So is that on the server? Okay. Use Nano. So you just type Nano. Okay. That sounds much better than Vim. So let's see. So that's an option if you haven't ever done text editing remotely on a server. And of course, we did all this. I think we got everybody connected to a server at one point the other day. And that's kind of the first thing that you're going to need to do is you somehow get connected to one. So I should preface this with, if you have home resources and you know you have Amber installed on those home resources and you know it's going to work, then use your home resources. Connect to your home resources and use Amber there. If you don't, then get onto the Exceed resources using this. Do you remember where did it go? Oh, here it is. So this is the thing that Michele has set up. And I guess there's not, yeah, it looks like there's up to 15 users here. If you need, I guess, can we have more than one person on? Okay. Okay. So it sounds like if you need to use the Exceed resources, because I already just went through this tutorial yesterday and it works, well, you got a few things. There's a few little bugs here and there because the tutorial was written over stages over probably 15 years and kind of corrected in some places and not in others. So there's a few inconsistencies, but other than that, it'll work, and we can get the little bugs worked out. But yeah, if you need to use Exceed, it sounds like use it. So you would get connected to these Exceed resources, and I'm just going to pull up where I'm connected, and remember, go to yeah. Oh, yeah, yeah. If it's going to work with Zoom, because it makes my computer freak out sometimes. Well, there we go. Okay, so I'm connected. I don't know if anybody has problems. Just right now, I guess the objective is get connected to whatever server you're going to use. And I'll give you a couple seconds to do that. Oh, yeah. Yeah, exactly. So when you get into, when you first log in, you're at your home folder, right? Like home instructor or home, whatever it is, student, I guess. And in order to get to the place where you really need to run this, you should go cd data, and then you will see all of the folders that you guys created the other day, right? And then you'd go cd into the folder that has your name. And that's where you want to, I even made a little folder here that's called TUT 51 for tutorial 5.1, just to keep things organized. And so I have my stuff in there. And I already ran it yesterday, so there's a lot of files in here from what we did, from what I did. So yeah, that's basically what you need to do. Get into your account. And this is going to be super easy because you don't even need to get a structure from the PDB or anywhere. The structure's already in Amber, essentially, okay? There is some Amber tools where you can actually create residues and other things. So it's quite handy that way that we don't have to bring in anything. Let's go back to the. So yeah, and it even says, make a directory tutorial. I called mine TUT 51, and then get into the tutorial. And from this point on, really, you just kind of, like, the first thing would just be type TLEAP. And magic should happen. This should pop up on your screen. So at least it did for me yesterday. And then you just type the stuff that's next to the arrows, right? So source, the next step would be type source, leaprc.protein.ff19sb, and then this stuff should pop out. Okay. One thing, if you're using your home resources, you may not have, I'm not sure what version of Amber is installed there. And if the 19 doesn't work, I would put in 14 because this stands for 2019, 2014. So if you have an older version of Amber installed, it's not going to know what FF19SB is. So you would have to put in some older version. But at least on the Exceed resources, it has, I believe, Amber 22. So definitely has this FF19SB. And you just continue to go down and type everything next to the little arrows. And I would suggest reading the paragraphs so you understand more about what you're doing, okay? And you've seen a bit of this already this morning, basic Amber force field and, blah, blah, blah. So this, I would read the little bits in between you typing these little things by the arrows, because it will tell you, kind of give you a better idea of what you're doing. And, that's about, there was one more thing on my PowerPoint that I was going to talk about. What was it? Oh, this is another thing that you may run into that will trip you up. So several times in the tutorial, there are long commands, and they break them up with this backslash character, which means new line. Basically, ignore the new line character and continue as one line. But if you just copy and paste from the website, sometimes that doesn't quite work, and it'll just run let me find an example of that. Let's go down here. So under the first time you encounter that, I think is point 15, and you go like this, you copy it, and you go over to your terminal window, or no, not that. That looked like terminal. Where'd it go? Okay, there it is. And you paste it in, and see how it did this is like putting it in as two separate commands, right? Will it? Yeah, I guess it did. Okay, cool. Well, it looks like it works. I was doing this yesterday, and yeah, it for some reason, sometimes it wasn't treating it as one command. So anyways, just be aware of that. If something looks like it's not working and you see a little backslash here, it may be because of the way you copied it, okay? Other than that, the other thing is, I'll hand over the microphone to Aisha so that people, if they want to get started on the GrowMax tutorial, they can do that. This is the Amber tutorial. Aisha's going to talk about the GrowMax tutorial. You got to kind of pick which one you want to do. I guess you could try to do both, but and then we're going to kind of split into two sides of the room, and then we'll go around and help you so that people who are working on the Amber tutorial are kind of together, and so we can go and help them, and the ones working on GrowMax tutorial are kind of together, and we can help you. But there's a few things about this. We're going to ignore, we're not going to use VMD, because number one, it won't work. And we're just going to use Chimera. I don't know, did we use Chimera yesterday or at some point? Oh, we used Chimera X. Yeah, so, I mean, I haven't used Chimera X ever almost. And so I don't really know exactly how it would work on Chimera X, how different it would be. But I would suggest visualizing your simulation using Chimera, and we'll show you how to do that. The other point is, so no VMD. And then this analysis, you can do this. I don't think it's very informative. I think the thing that you should probably focus on would be the RMSD analysis, okay? And it's this, use CPP trash to analyze the RMSD. As far as this other analysis stuff goes, it's a little bit, some of it doesn't work, and also I don't know how informative it is. So, yeah, I think does anybody have any questions right now about what we're doing or how to get there?
GrowMax tutorial. Hi, can you hear me now? Okay, I'm going to repeat the if you are a genomics student, please follow the Amber tutorial because you have not been assigned a GPU. Professor Aisha will be using GrowMax, and this will require the GPU. And therefore, if you don't have it, it's just not going to run. Thank you very much.
So we're actually there. You have the GPU. Oh, so we're going to use GPUs with the GrowMax.
For GrowMax, we're going to be using GPUs. Yes. Or for GrowMax, we're going to be using the GPU-dependent command, and that will not run unless you have it will be blocked because it won't detect the GPU.
Okay. Yeah. Okay. So we are using CPUs to actually do the simulation in both GrowMax and Amber. It's just okay.
Yeah. Yeah. It's just that for people that won't have the GPU, GrowMax will just be like, hey, something's missing.
Okay.
So you don't want to run into that. Yes.
I am in MD group, so I'm gonna know that GPU is available for me.
If you are in the MD group, in order for you to pull up the GPU, you do NVIDIA/SMI. Yes, and that will just pull up the CUDA.
And I just wanted to show what your goal is. Eventually, when you do your build and you're ready to do your simulation, this is sort of what it should look like if you pull it up in a molecular visualization software like Chimera. There's a bunch of water molecules, and then in the centers there's a little alanine dipeptide, little alanine. Okay, that's what it should look like when you're done with up to about point. Let's see. Yeah. Anyways, when you visualize it and I'll show you guys how to visualize it in Chimera once you get to that point, which would be, let me see, where's that point at? It's where it says VMD, of course. So visualize the results. Once you get to here, I'm going to have to help you, or unless you know how to use Chimera really well, then you can do it yourselves. Okay? All right. Any other questions about this tutorial, about the Amber tutorial? All right, so I'll hand it over to Aisha to introduce the GROMACS tutorial. After Aisha's done, remember, we're going to, maybe that'll be lunch. And then after lunch, we'll split into two parts, GROMACS, Amber, and then we'll help you complete the tutorial, okay? Individually.
Hi, everyone. So Travis has done a very good job with showing you how this thing works. Oh, so thunder is there when I speak. Okay. Okay. So I'm going to show you how GROMACS runs, and GROMACS is another software, okay, that is used for MD simulations. GROMACS is free to use. That's I think the best part of it, because Amber is by subscription. So when most of us, okay, when we are not subscribing to this Amber, although I think that Amber has got a lot of functionality and it's regularly updated also. However, you can run some very good simulations actually on GROMACS also, and it has got some really good ones, which I think that I have used most of them actually. So just to introduce you to some of the GROMACS, I hope it loads faster. Okay, let's go back to the introduction. Okay, and then I'm gonna take you to the tutorial home. Okay, so these are the basic 6 or 7 of the tutorials that have been created and I'm gonna use. So what you can do with GROMACS is already set for a few things. Number one is that if you have a protein folding problem, you have designed a new protein, just a peptide, and you'd like to see how it folds into 3D structures, or you've mutated it and then you'd like to see that how does it fold with the mutation. So you can actually use this very basic simulation. I've used this very often. This tutorial that shows it, you can also run a GROMACS with membrane simulations, and it runs very well actually. You can also do some stir dynamics. Stir dynamics is that you have got proteins. You've got some proteins and you'd like to see how strongly bound they are. Or you'd like to see whether how well they move from one place to another. The whole protein, you can actually move it through using the umbrella sampling. One part of the umbrella sampling is stir dynamics, in which you can actually pull it up. This peptides, group of peptides that's given, this tutorial actually takes you through how pulling them apart will help you. And I have personally used this tutorial. I've combined these two tutorials together actually. I pushed one protein right through the membrane to the other side. Okay, so of course you have to be careful because you can pull anything through because you're applying a force and it's on the computers. However, if you are careful with your the type of force that you apply on it, you can actually simulate, get a good prediction of your systems also. Okay, and then this is one that most people follow, which is the protein ligand systems. Okay. The protein ligand system is the one that's given here. We're not going to do today that, but if you need help, I'm available. I can help you through it. Okay. This tutorial, it has become a bit complicated. It was very simple previously, but it has become a bit complicated now, and it requires a lot of softwares to be downloaded and worked through. But we can make it a bit simpler from what we have done previously. Okay, so so for today's simulations, what we are going to do is, just may I ask, how many people have used GROMACS or use GROMACS regularly? And just a simple one, or protein ligand systems are there? Protein ligand systems? Okay, you've done this, so, okay, okay. Anybody else? 1, 2, you've run through and no hitches. I believe no hitches. If you just follow it, no problems, no issues. Yeah, it runs quite popularly. So do I have an audience where not many people have used it? Okay, so we so we hope we can get you interested into doing that. Okay, so this tutorial is quite tried, tested one, and if we follow it as such, we will be getting through with it. And it's also just command line based, and I ran it just now on the server. It runs very well on the server. So on the server, just to let you know, we have created this. You've got your folders, right? And there is in Slack, I think. Okay. Was it here? Caleb, may I ask the command? Sorry, I'm going to that here. Okay. Where did we put that command line?
In the private message.
Okay, so we
just go to our chat.
Huh?
If you could just go to our chat. Yes.
Okay.
Yeah, and just copy this and tell people to do this one.
Okay.
Computing resources or lecture materials is also.
So I'm going to take this last one.
Just going to put this.
Okay, I put this command line here, okay? If people can follow this, go to your own folders and you can copy, it's already in the shared folder, we put the tutorial there. Just copy it inside your folder so that you can do it on your own side, okay? So just copy paste this and then I suppose we should be able to get there. So for this tutorial, actually, I've created a docx file. Okay, so this is a docx file you'll get into in your folder. Okay, so, and in this one, you will get, I put basically all the command and all the steps that you can take just there. Okay, you don't need to follow the step 1 and 2, you just copy it into your folders and then we can just start it from here, okay? And then it tells you how to, get the file if you're doing it on your own, but I've copied the, I've downloaded and put the file there actually, okay? So we can start it right from there. But if anybody is interested in downloading your own files, you can actually follow this command line and then you can get through there. So we'll have to start from here, cleaning up your protein and then all the other command lines. So just copy pasting here, nothing changes. I mean, I use this. the only thing that it's different from the why I did this was because there is in this one they use a GMX, okay? So if you can see this, they use just a GMX. GMX is of course to get GROMACS, but GROMACS on a single what do you call single use single node one, okay? So I already asked Michaela to install it on multiple cores. So we are running an MPI version of it, an open MPI. So therefore, the command line would be gmx_MPI. So that's what I made the change as well in the tutorial. So now you can see that it's gmx_MPI. So that's why it will be a bit easier for you to copy and run the command lines. And so we just follow it through, and then we see. Okay, so I thought we had VMD, but if we don't even have VMD, we can open it in Chimera and see. It just works fine with Chimera as well. Okay, so when we get there, we'll do it. Again, just like Travis has said, in your files, actually, you will have this. I put all the files here. They are already in your folder that you will download. Okay. So this MD, the others are okay, but here, this one. Okay. Okay. All right. So here again, it's a 10 nanosecond one. It's quite huge. It will take a long time to run. So again, this one also, we are going to reduce it to, let's say, 1,000 picoseconds. 1,000 picoseconds is 1 nanosecond, so we'll just reduce it to 1 nanosecond. So we'll go like 50,000 and see how 50,000. And then we should be able to running 1 nanosecond. It should run faster. That's why. Okay? Just for the purpose of running and letting you know it runs. Okay? Other than that, we'll use the standard things. When we get there, we'll do a bit more explanation of what is inside the files. Okay? And these are all the parameters that are necessary. Some of the parameters are for the how to equilibrate it at a temperature. All systems need to be equilibrated on a system. They are not naturally, when you get the crystal structures, they have all kinds of clashes that might be there between the side chains of the proteins, or if there is a ligand there might be some clashes there. So we need to minimize, and we need to remove the clashes, and then we need to equilibrate them, or let's say bring it to it's like bringing them into an environment, creating an environment into which a simulation can be run. Okay. And then again, this will run on a CPU today, I suppose. And then if you run it on a GPU, it runs very fast. Actually, it can complete 10 nanoseconds. Is like if you have a microsecond one, it can run in a few minutes as well. Okay. So GROMACS by many is very preferred because it's a very fast way of doing simulation. They say it's one of the fastest actually. I'm not so sure, but for me also when I run, it runs okay. If I run it on a server and it runs on multiple cores or it runs on the GPU, it's quite fast actually. I can get my results within a day. I have run Amber. A simulation runs faster, no problem. But when I start to do the calculations, it just holds up quite a lot actually. Okay. And here in GROMACS, even the calculations can run fast. It's not such an issue there. Okay, so we'll be, okay, so when we get here, then we will run through these tutorials with you. Okay. Any questions for people who haven't used GROMACS? Anything you'd like to ask? We are not doing the protein ligand systems. I understand from the requests that were given to us that many of the people are using protein ligand systems. I can help you individually to know how to prepare those systems also to run. Okay. However, for today's purpose, we just follow the class and we just run this. Okay? Is that okay with us? I hope people are not bored who have run that. I hope they can also continue with us. Okay. Anything else you'd like to ask about GROMACS? Okay, so if we would be concerned that whether we get, why do we use GROMACS and not use Amber? Or what is the difference maybe between using Amber and GROMACS? Frankly, I'm not so sure about that. What's the difference? I use GROMACS because it runs faster, that's all. Okay, and it's free to install on my computer, and anybody can install it and use it. That's the only reason I would like to use it, okay? Yeah, but it's free to use, so that's I just install it and then use it, and then I find that the tutorials are quite well defined. So I don't run into many issues, and there is like Amber, there is a huge community actually that helps you run or smoothen out or iron out your problems if you come across any. I personally had a lot of issues when I was doing my membrane ones, but then I found some good help online, and I was able to do that as well. Okay.
So I just want to add, actually, the Amber we're using today is totally free.
Okay.
The only thing that you need to pay for is the engine to run GPUs with, and yeah. See, we have the Amber GROMACS. All right, so I think it's lunchtime, right? So we'll come back, and if you could, maybe we have Amber, people who want to focus on the Amber tutorial over on this side, and then maybe people who want to focus on the GROMACS tutorial over there, so we can kind of talk to you more easily. All right, we'll help you individually get through these tutorials.